Hello folks, well it's the 27th of December, so Christmas is over and I don't know whether we've got that record processing, that Huddersfield Choral Society singing hymns record, whether that's happening before or after this video. So you'll remember that we've got in a DNT Scanner 40 which was kindly donated by a viewer, and it's come with this microphone, this M1 microphone, which wanted wiring. So I'm sure I've got the wiring right, I've not looked into that, but the trade has sent me a photograph of inside one of these microphones, and one of the viewers offered to send me the inside photograph of one of these microphones, and then on top of that, the person who originally donated that radio has actually sent me a generic microphone as part of some deal which I'll look into later, which works on that, because he didn't want me to blow up the radio when the transistors arrive for the receive regulator, which has failed. The transistors have arrived, but I've got other things to do. So in the meantime, and I don't undo boxes normally, but I've just undone this. Why am I so thrilled to have a DNT M40 that I've just bought off eBay for £10? One with feet on the bottom. It's really got to be very unsuitable as a base station. No screws in it. Advertised as spares not working, and for spares parts, whatever. Just quickly open this up. Make sure there's some innards. Oh my goodness, it's got a transistor on the bottom. And it's got... Well, we're going to have a look at this. We'll do this is what this video is about. We're going to have a look at this. But if I end up using it for parts, well, I end up using it for parts. These were always unreliable, and somebody's put a crystal filter in a hope to get rid of the bleed over these gets, and they can work quite well, but whether or not that's been implemented properly is another question. If we get it to work, we'll flog it on. I don't need any more DNT M40s, and of course we're still working on that B40, and I just want to show you the final bit of that before we send it back. But the reason I bought this, and here's the printout. It says here, and just before we show you this, I'm just going to cross out the vendor's username. Right. It says DNT M40 CB radio, CB ANS receiver. What's that mean? Is this has somebody hijacked an overseas thing? I don't know. Doesn't help you sell it, does it? CB ANS ANS receiver. Condition is for parts are not working. Dispatch yodel. Right. So there's the title. DNT M40 CB radio, CB ANS receiver. Now I only speak English and Morse code, so I've no idea, but they haven't helped themselves. And here's where they really haven't helped themselves, because they should have sold this as two separate items and got more money. It's come with one of those DNT M1 microphones, which is totally unsuitable. So here we are, a DNT M1 microphone with the right 8-pin plug for the DNT Scanner 40. Isn't that handy? We can have more microphones for those now than anything else. So this has not come with a microphone. Now, if they'd have sold this as a grinning radio and started the bidding at 10 quid, you know what, they might have sold it, it might have gone for 15 quid, who knows, it might have gone for more. If they'd have put that microphone on with a starting bid at £9.99, they might have got 35 quid for that microphone. But I think, I mean, the other side to this, you might think that they go, oh, There's going to be some mug by that, and the mic doesn't even fit. Oh, you don't know whether they think that, do you? Or whether it's a genuine. It's not being pointed out that that's an 8-pin mic on a 5-pin radio. That is my best purchase for 2024. Doesn't matter how rubbish this is. We've got a DNT M1 microphone. So I will go and get. We'll pop those lids to one side. And I will go and get our standard replacement microphone. So I say I don't normally open mail, but because I'd had notification this had arrived, and that was a CB radio size box, I thought we'll do that because Mr. Chippie's not here today, and so I thought we'll get on, do a CB video and kill several birds with one stone. That capacitor's failed. We've got to change that first. So here's our DNT standard replacement microphone with a 5-pin plug on the end. Right, we'll put the soldering iron on. So I don't know whether you can see, but that's knackered. So there's no point powering it up because it could be killing the audio IC, which may already be dead. Oh my goodness, what's happened under here? I know these are 40 years old, but well, at least I don't think I've got to solder amongst all the soldering. I think it's that part there. We'll just try and ease it out before using the solder sucker. Yeah. Not a lover of these boards. Oh, got it out. Of course, it fell out at the last minute, didn't it? What's it supposed to be? There's its sleeve. .7 microfarads. So where's the actual capacitor rolled? There it is. You look well if it works. I've just been doing a Valve Philips tape recorder and changed about 15 capacitors, and then the last one is the one that didn't work though. Well, I don't think it would have blown up. But 3.7 microfarads, I think most of the horses are bolted there. Right, I'll pause this, go and get a capacitor. Okay, we've got a Nikon capacitor, so the capacitor's going to be worth more than the radio. We've got a scrap chassis here, so we can see which way around it goes, because the sleeve was no good. And it's negative to the top. Yep. So I'm sorry that we're doing 2 consecutive DNTs with that base station and this. Sometimes that's how it goes. But if this is in a knackered condition, well, I'm not sure we're going anywhere with it. So before we apply the mic, let's power it up. Okay, well the meter lamp works, and at least it selected some channels. However, I haven't got a channel free light. I'll plug the mic in. I'll plug the test instrument speakers in. Plug in the test set. So far we've got no audio. We've got no transmit. We've got no receive. We've got no channel free light. Well, I'll start by having a quick look for dry joints, and then what's missing from there. No, nothing's missing. It's supposed to be missing. Yeah, I mean these have always suffered from dry joints, something chronic. So we'll have a quick look at that. And in fact, I've got no audio. So the question is, have we got an 8-volt rail? So I'll get the meter out. So there's a limit to what I want to do to this. It's maybe a short video of nothing. See whether we've got positive. Well, I'll see what we've... Yeah, it's negative chassis. So we've got a diode here. What have we got on it? We have 8.5 volts. And we should have 8.5 volts. So... I suppose the next quick test is to actually probably look at the relay contacts to see yes, so you get full rail voltage to the receive. It's not 8 volts like you normally would have, and you get full rail voltage to transmit, and then you've got a 9 volt Zener there. So we need to see whether we've got rail voltage up at the relay. So it really doesn't matter which set of contacts I'm looking at. We've got nothing on that one. We've got nothing on that one. Nothing on that one. Nothing on that one. We've got 13.8 volts there. Obviously we've got nothing there. We should have 13.8 volts there. So we have got our receive rail. Not sure about the soldering just now. Just pop the power off. We need to do suffer from dry joints. Badly. I've already lost my place. There it is. Because I'd expect the I would expect the receive busy light to or channel 3 light or whatever it is on these to be lit. It isn't going to go into transmit if the phase out loop's not running, so I do accept that, but I've not got the channel 3 light. We've got a switch on thumb. Who's to let's put a big signal on anyway, because if I put the signal generator on channel 20, got a whacking great big signal. If I put my walkie-talkie on, we'll hear that, no doubt. I would have thought. Oh, we're on CPT, aren't we? Yeah. So I think we're now looking at the fact the synthesizer's not running, but here we go. Why haven't we got audio? Who's to say the audio IC works? It's certainly been messed with. If I've got a bench amplifier on here, we'd look at it on the volume control, but although I've got 2 bench amplifiers, I think they're both on Mr. Chippie's bench. Because, you know, if the audio RC is not working, we're not going to have any audio. It's certainly being messed with in that direction, but I'm expecting the channel 3 light to come up, and it isn't doing, so see whether the synthesizer is running. So I'll start by looking at the, well, see whether there's power on it for a start, and then we'll look at 10.24 and take it from there. Pin 3 and 4 is 10.24, and our power rail looks to be 1 and 10. We've got 7.8 volts there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got 7.8 volts there. So that looks right. So we'll get the oscilloscope out. Use it as a frequency counter. Although the test set's got this kind of facility built into it, it's just bit handier to use this, especially for a demonstration where we've got the overhead camera. Right, pin 3 and 4, we said there's pin 3. And 4. We've got 10.2388. So we may as well adjust that, because it wants doing anyway. So we're going to have to spot pause. There we go. So we know that's running. So that's a good start. Of course, all these cores look slightly on the broken side. Take that away. This one looks messed with. That's a strange phenomenon. I'm getting, when I key this, I can hear. Hey, we've got something happening there. When I key up, I've got a short circuit, so it's shutting down the power supply, which is set for 2.5 amps. So that was out of adjustment, so it must be trying to generate something, but we have got a short. We're not got anything showing on receive. So have we got a short, is the question. Or have we got a duff output transistor which is short? What I'm going to do is, I think we'll assume we've got a problem with the output transistor, because there's no obvious short circuit, though that is unsoldered. Why would that be unsoldered? Because it's been bent back. Why would it have been bent back? It looks intact. Perhaps somebody else was looking for a short circuit. Right, we'll just put that capacitor where it should be. So two things here. If I remove this transistor from the heatsink, just in case the insulation kit's failed, and then if that doesn't cure the short, we'll remove the transistor. Still got a short. Right, I'll unsolder this and we'll get back to you then. Okay, so we've got the transistor out, so let's now see if we've still got a short. No. Does it actually transmit? A few inches. Turn the signal generator down a bit. No, it doesn't. So we'll test the transistor. I've dropped a thing of screws, so whatever they were out of, they're not now. That's not the transistor tester. That is CB27. Yeah, I mean that works. So good. The gain is 49. Notice when you buy these fake ones with gains of 270, you know they're fake. Well, I'm not going to bother putting that back, and because the set isn't yet working enough. So that'll drive a transistors there. So let's see whether we've got any RF on it. With the diode probe. Power it back up. And find where my driver transistor is. It's there. So we've got a coil. So it's going to be those three terminals. And at the moment we're drawing 150 milliamps, when I key up we're drawing 220 milliamps, which is kind of promising. I've got RF there. Let's put it into high power. So have we got any power to the transistor? We have. So, well, that doesn't seem to be amplifying. I've got no idea what frequency it's doing either. It certainly isn't here. We'll leave that for now. Okay, so it's the next day, and the executive decision is not to pursue this any further. So we will move to a different set. We can recover the relay out of that. We know we've got to change the audio IC. We've got to find out why there's 2 volts going up the audio. We've got to find out why the phase lock loop's not working, although the initial oscillator is. We don't know what's happened underneath. So, and we need to know why there's a short circuit when you actually get it to transmit. So, we bought it as scrap, and you know, the logic is if I spend, I mean, what's minimum wage? £12.40 or something. Well, now I've spent £12.40 on top of buying that for a tenner, so it now stands to make 20 odd pounds. So if I could fix it with no parts in 1 more hour, nobody's going to buy it for 40, are they? So we're at a dead loss. Now this one's been kindly donated, and it says Duff power lead. That's fair enough. No transmit power, no receive, no transmit, and low transmit audio. You never know. Right. So again, we'll have a quick look at this. If it can't be done in 40 minutes, then another one will have to go. Don't want these coming in for repair, to be quite frank, because they are past it. Especially if they've been messed with. You know, if it's the bog standard one which hasn't had the filters and that, we've got a fighting chance. Sticker on the back, which if Mark's done it, will mean it's what we call trade working. So it kind of does a bit of something. I'll put the soldering iron on ready. At least we've got some screws with this one. Corrosion, we're going to take the bottom lid off. I'll wait for the soldering iron to warm up. So let's take the bottom off, see whether that corrosion is problematic. I mean, once again, it's like looking at the same set. It's either had the audio IC changed or whatever. It's had to have the diode put in because of reverse polarity. I can see that's a dry joint before we even start. I don't know what's supposed to be there. Let's look at this one, which is decent-ish. What I can't tell is whether we've got... No, I thought we got a possible broken bit of track there. I think the safest thing to do is to actually blob that across to the next pin. And then check for continuity. And that's before we've powered it up. Yep, that's okay. Right. That looks like a bit of meter lamp. It's like 1 in 4 of these which are now fixable. Right, well, we've got no capacitors which are bulging, so that's a good start. Why have we got the top of the screen missing? I don't know. Power supply on. It's powered up. Something wrong with the display. You can see it's actually receiving because the signal generator has just been picked up. It's not necessarily on channel because it's just been switched on, but it is, we can see it's receiving. So we'll plug the mic in. It is transmitting, but it's not transmitting into the test set. Have you ever got to the conclusion when you start to think, is the test set working? Using my walkie-talkie, let's just look at the output to my walkie-talkie. I'll put picture in picture on into the test set. So key up, yeah. 3/4 of a watt. Are we on low power? Yeah. Right, so at least we know that's not dodgy. Just check we haven't got a dodgy socket. Now, I'm still not getting much out of the set, so I don't quite get what's happening there. Testing 1 2, testing 1 2. no receive audio. Let's put the signal generator on so we know it's on channel. So we can see we've got the signal generator. We can see it's receiving. There's an S9 signal. That doesn't look very S9 to me. Let's put it into DX mode. That still doesn't look very S9 to me. We'll see what it sounds like. We'll bring back the bench amplifier, which I didn't want to drop. The Tango 21 bench amplifier. And listen at the volume control. Let's put an earth to that. These had PA, it would make them so much easier to service. So we'll turn the attenuator down. That's 1 microvolt, which, although noisy, isn't showing that the set's stupidly insensitive. Not sure how that filters on some angle, but there you are. Why would that filter be on some angle? How could it be inserted so badly? Anyway, it does prove to us that the receiver is actually receiving, and it's not far off what it should be. So we'll put that back. So we've got no audio because the audio RC is no good. It's been reverse polarity, hasn't it, just like the other one. But that doesn't tell us the issue with the transmit not actually getting out anywhere. So I think for that we'll get the big Russian meter. Right, I'll put it on really insensitive range. I'll go on to low power. So if I remember rightly, where's our... I'll have to see where it is visually. It's there. I think that's the driver. So the output transistor is here, which is lower. Honestly, can't see where the track goes. Is it burnt out? Turn the power off. No. Some nasty residue. Turn it back on. It's got plenty of amplification. So where is it not going is the question. Is that our output? It is. Have we got a duff relay? Is that where our output it should be? Yes. I've got no continuity somewhere. What's that nasty bit there? Turn it back off again. Right, to see whether that's hit any dry joints. And the answer is no, of course it hasn't. So it's drawing the right transmit current, but it's just not getting out. It's developing the transmit. So we're losing it in this filter somewhere. We're also losing the power because I've wrapped it round so many times. Anyway, I'll have a look at that off camera, and no doubt I will find that. Okay, so I have been to the other workshop, seeing as Mr. Chippie's not here at the moment, and I've changed some parts. I've removed the obviously knackered audio IC, cleaned up around it, and what I've done is to remove the entire filter chain all the way from the output transistor out. So on the square kit diagram we have the output transistor here. I've changed the electrolytic capacitor there in the low power circuit just because it was there, and I took it out, it was in the way, to put a new one in. And then we've changed 100, 56, 390, 68, 220, 68 and 100. Now I'd have liked to have put all better quality ones in, but I only got 100s in stock, which is that one, which is much higher quality, 2000 volt rated one. These are Billy No Mates capacitors, and I've taken them off the set which we bought, which was now scrapped, and apart from one which I felt was slightly out of tolerance. So I've also used the coils from the other set. Now that other set hasn't transmitted probably for 35 years, and you can tell because you're going to get heat, aren't you, when you're using transmit, and you're going to get dust being attracted to those hot areas. You're going to get discoloration, and that set's got no discoloration. It's like a new set as far as the transmitter goes. It doesn't transmit, hasn't done, it's been messed with, it's been ruined. So all that has been removed, the board's being cleaned, and it's being put back. Now of course, whether it works, and while I had these coils out, I made sure that the soldering of the actual coil of wire to the pins was redone as well. I'm not going to plug the speaker in because we've got no audio IC. There's no point putting one in because we may still be scrapping this one. But I've put now 90 minutes into it, so it's not something we want to do. So let's hope it does better than what was it doing? Just look at where we were. It was doing half a watt on full power, but drawing enough current that you'd expect for full power. So it's kind of internal SWR was wrong. Right, let's find the mic. How can I've lost that? Alright, power supply on, radio lights up. Wow. Huh. Is the meter still on picture in picture? It is. So I haven't touched any of this, and straight away we've got more than 3 watts. Now unlike Cybernet sets, the audio IC doesn't have any roots in some AM design, and so it isn't used as a preamp, so we shouldn't have a problem with audio. Let's just put the walkie-talkie on. Testing 1 2, testing 1 2. So you can hear we've got audio. It's nothing to do with the audio IC, it comes a different route. So well, there we go. So that the low power, we don't know what the fault was, but I just changed it all. So that was the thing to do. Right, we'll go over to the 30 watt scale, and our 4 watt mark is, it's doing 4.1 watts. And what we've got to do is to actually, I'm loath actually to touch this because it's been tuned up and sealed and it's going to be right. So that's not been changed for donkey's years. The set's doing more than 4 watts, and so I don't think there's any reason to do anything. So we'll just go through these filters. So just peak there at 4.5. Still got to peak it. And drop it on there, and let's hope nobody's touched that one in there, which is to do with the second harmonic. We'll find that out when I do it on the air test with Mr. Chippie. I don't want to go to the time and expense of using the spectrum analyzer when I don't need to. So we just assume that's not being messed with. Because I can tell instantly when we're on the air test whether there's a harmonic or not. Right, so we'll go through one or two of the things because it's. I'll put the big Russian meter away. We'll get out the oscilloscope, set up 10.24. Switch that on. So although I've got no receive, we have got receive. You've already seen that. I'll just check we still have 2779. Put the signal generator on while the oscilloscope comes on. You can see we've got a signal exactly as we had before. Just can't hear it, just like we couldn't before, except we used the little amplifier, didn't we? So that's high power set. Let's just get this on frequency, and it's this silly arrangement with a multiple crystal mixer, and so we've got to go through all this faff. You can't just twiddle one thing like you can on most sets. Get an earth on there eventually. Alright, so there we have 10.2389. So if I can get that with my other hand. $23.99 will do me. So that's set the 10.24. That's vital. As shown before, we have to use a second signal generator to set the other, because you've got the crystal mixer for the receiver, crystal mixer for transmit. So now we can do this one for transmit. So let's go over to the appropriate camera. And then it's dinner time. So what have we got? 2779023 isn't too scary. I can't remember whether it's that one or that one, so we'll go for that one first. It's not that one. Now hopefully it will go on receive, otherwise we've got to start doing a compromise. 2779124, that will do me. So it's now on frequency on transmit, it's doing 4 watts, and So the meter is one of these two. TX meter is the lower one. It wants to be in the centre of the red zone, which it is. Then on low power it wants to be doing 400 milliwatts. So let's go back to the main meter. And 400 milliwatts. It's currently doing 220 milliwatts. Remind me which one it is. It's going to be that one, isn't it? Oh, that's dirty. That might be too dirty. Let's see. Let's waggle it round. No, it's done it. 400 milliwatts. And now we'll just look at deviation for what it's worth on this test set. Wallow. About 1.5. So I'll adjust this on this end and we'll look at it on the other test set. Wallow. So that's now set on this test set. Let's see what it sounds like on the talkie-walkie, which we'll put the aerial back on. Testing 1, 2, testing 1, 2, 3, 4, 5. Good. Okay, so the next thing I'm going to be doing, I'll come back from dinner, put the a brand new audio chip in there. I'm not going to start trying to recover them because most of these have been blown up through 24 volts or reverse polarity, and they're difficult to recover in one piece anyway. Now, when I took this one off, a leg fell off, and it doesn't mean it fell off because I pulled on it. It fell off because it was, I think the word is knackered. Okay, so I've changed the audio RC. It's now back on the bench. There's the audio RC inserted. Got it connected up. I've got it on the extension speaker we use for PA testing rather than the test instruments. Oops, better put the power supply on. Oh, good. And the squelch works. Right, I'll put it on the test gear. So what we've got to do is first of all check that we're on frequency. 27.79128. Let's get that exact. Because what we're going to do, I'll get it somewhere near on frequency just by listening. Well, that sounds something near, doesn't it? Now we'll get the second signal generator out and we'll see whether we can set it up something close. Turn the tone off, machine on. Can we hear that musical note? Try and nullify that. There we go, we're on frequency now. So 10.695 from here, 27.79125 from there. And if we change the frequency, it has exactly the same effect. We can now go through with the synod meter. Tone on. Start with the detector, just like we normally would. Camera 3. It's one of those, can never remember which. Okay, that's somewhere near. So front end, and is at the IF. Back the signal generator up a bit. We've got 0.9 microvolts for 12 decibel cyanide, which is what we're going to expect. So there we are. Just double check this one. Just go back to the detector. You know when it's been miles out like this. Well, I think that's where we are. Let's go back to sensitivity. .85. So we can't do it before on this because it wasn't working. What did we say? 0.85 for 10 dB, 0.75 for 20 dB, 2.5. RF meter is correct. S meter needs setting. So it's 100 microvolts on the signal generator. Let's see what we've got on the meter. Not quite. So it's that adjustment. That wants a bit of a spray. We're now at S9. RF gain works. I don't think they have squelch, do they? No, it's one of the many letdowns. So low power, deviation, transmit meter, receive meter. Put that meter away. And we'll plug it in the other test set. Let's see if we can get deviation reading. So I fiddled with the deviation, if you remember. I got it to where it looked right on the Marconi test set, but we can't trust that, so we'll go to the other test set. Wow. Actually, it's tiny bit low. It's 2.2 with an absolute peak. I want a 2.5 absolute peak. Wow. That's it. So back to the Marconi test set. And just for giggles, we'll see what it says on here. Wow, it says 2.5 peak, just like it did on the other. So it must be okay today. 25, 26, 27. 28. So you can see why nobody was getting anywhere with this set, and I just had to change all those capacitors and all those coils. Just do a blanket job because something's leaky somewhere, and it could have been iffy soldering on one of these coils. I don't mean on the board, but actually in the way the coil's made, and it could also be a tracking on one of the capacitors. But it is quicker to spend 90 minutes changing the lot rather than try and get to things piecemeal. It enables me to clean the board properly, and so we then use the coils from the other set, which clearly are not transmitted for decades. So there we go. So I'm very satisfied. It's nice to see full 4-watt output without any squedging, squealing or anything. It's actually doing it. We can listen to that.
Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
It's lovely. And on receive, is it any good? I mean, is it not good on receive, are they?
Testing 1, 2, testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
So you know, it's there. That's why people start changing filters and transistors and things. And yes, they can get them to be better and try and emulate the Supertune version, which was reworked by Cleartone, who of course do police radios. So you know they worked out a way to do it, and it worked out. But they made the sets expensive, and it didn't help the reliability. But they will always say it's the Supertune version on here. So when you come across them with odd filters and odd transistors, and they haven't got that on the front, you know someone's just kind of an engineer or an amateur's done it, and you don't know whether the set ever worked after them having done that. So one last thing for us to check, and that will be squelch operation, which is bound to be dreary. So we know we've got 400 milliwatts. And let's just look at transmit current. We're on low power, 1.14 amps, which is what you'd expect. And it's, change scales. Yeah, it's cooled down and drifted high. Don't mind leaving it at 4.1. Channel 1, 4.1, channel 40, 4. Deviation is now 2.2 to 2.5 peak. That's reading correctly. That works. Those works. That will have to be cleaned. Vol control cleaned. Sockets work. Doesn't have one of those, and we don't know about the speaker. So just got squelch to check. Okay, so we'll set the threshold on the radio. We've got the signal generator parked at 0.3 of a microvolt. Let's put the attenuator on the inset picture. So at 0.3, switch it on, nothing. So where does it come in? Yeah. Well, Wally, I'm on channel 40 still. Okay, we'll do that again. So squelch. Signal generator back on. Just about in. 0.58. And we'll look at where maximum is. So sensitivity 0.58 microvolts. That's great. Now we'll turn the squelch to full, and we'll now see where it is. It's going to be pretty wishy-washy. Well, it isn't, is it? Oh, well, that's great. It never comes in at all. Well, there's nothing unusual there, is there? So at what point is the squelch operation? Yeah, it's one of those where you can't have the squelch quite so full. So if you look at it, that final section, we can't get a signal up there, but it's the way they are. It's why it's so much better when it's got an internal preset. Never opens. But there we are, it works at the bottom end. I'm sure somebody loves these sets, but it ain't me. Well, we want a lid. We're better off with the lids this came with. Are we? I'll tell you what. We'll use we'll do a bit of swapping there. Better speaker lid. One that hasn't got a hole in it. So we're doing on the air test when Mr. Chippie gets back. And then no doubt this will end up on eBay at repair cost only. But that repair cost is quite substantial. And of course all those dry joints, while I was going through them, I sorted the display digits out as well. I'll clean that up a bit, just a bit. Just put a few screws in for now. Okay, now go to internal speaker, and then we discover the internal speaker doesn't work. Yep, internal speaker doesn't work. You couldn't make it up, could you? So back to the original speaker lid, won't it? Sure we haven't got a wiring problem. Okay, so we'll get the multimeter. We'll make sure that this speaker actually says it works. .2 ohms. The speaker we will try to put in open circuit. Right. Well, that's clinched that then. So we've got a double whammy there because we've got a dirty switch. As well as an open circuit speaker. Of course it does help if you can solder. Okay. Right, I'll plug the aerial in. One nano Roger. What we'll do, we'll just once final time use the walkie-talkie.
Testing 1 2, testing 1 2.
Good. It's not going to say anything, is it? Okay, we'll do an on-the-air test in due course. Thank you for watching. Dread to think how long this video is going to be. Kind of half did the other set and realised it was hopeless, and at least it's been useful. Thanks for watching.